Chapter 3, The World of Numbers. We will look into the different types of numbers in this particular chapter, namely the natural numbers, which is represented as n, which starts from 1 and goes on till infinity. These are contained in the collection of integers, meaning the integers contain these natural numbers as well. Now let's look into what are integers. They are the positive numbers, the negative numbers, including 0. These in turn are contained in the collection of rational numbers. So this rational numbers includes all the integers. Integers once again includes all the natural numbers as well as 0. So the whole numbers comes under integers and the integers comes under the rational numbers. Now, what are rational numbers? These are the numbers which can be represented in the pattern P by Q, where P and Q are integers and Q should not be equal to 0. So, they can represent those numbers with terminating decimals and repeating decimals, which we will be looking into in detail in this particular chapter. There are other numbers which are called the irrational numbers also, where it cannot be written in the form of fractions like P by Q, because if you can write a particular number in the format of P by Q, it becomes a rational number. There could be other numbers like pi or the square root of 2, for example, which cannot be represented in the format P by Q. And why we cannot represent them also we can see in this particular chapter. So, we have seen the collection of rational numbers, irrational numbers. The rational numbers, once again, as a quick revision, what does it contain? It contains the set of integers. Integers contain positive and the negative numbers and 0, meaning it contains the set of whole numbers, the whole numbers, which in turn contain the set of natural numbers. Now, let's look into what are the real numbers. This is the superset of all, meaning the real numbers can contain both the rational and the irrational numbers. The set which contains both is called as the real number. Exercise at 3.1, sum number 1. A merchant in the port city of Lothal is exchanging bags of spices for copper ingots. He receives 15 ingots for every 2 bags of spices. So how much is he getting? For every 2 bags, it is 15 ingots. Since the number is 2, we can very well find out the value of 1 bag. So it is nothing but 15 divided by 2, which is 7.5. If he brings 12 bags of spices to the market, how many copper ingots will he leave with? There are 12 bags. We have already seen the value of 1 bag, which is 7.5 ingots. So for 12, just multiply it by 12 to get 90 copper ingots for the 12 bags of spices that he has carried out. Sum number 2, look at the sequence of the numbers on one column of the Ishango bond 11, 13, 17, 19. Looking at these numbers itself, we can find out that these represent the prime numbers. What is the quality of a prime number? The prime numbers have only 2 factors, the number itself and the number 1. So all these 4 numbers share the common quality that it has, each one of them have a common factor which is nothing but 1. So it indicates that all these 4 numbers are prime numbers. They lie between 10 and 20, and the next 3 numbers that would fit this pattern would be, what are the next 3 prime numbers after 19? They would be 23, 29 and 31. We know that the natural numbers are closed under addition. The sum of any 2 natural numbers is always a natural number. That is the definition of the closure property of addition. That is, if you add any 2 number, the value whichever you are getting should also be a natural number. That is the closure property. Now they are asking, are they closed under subtraction? It need not be. Say for example, 5 minus 12, where 5 and 12 are rational numbers, but the operator is subtraction. You get minus 7. 5 and 7 are natural numbers, whereas minus 7 is not a natural number. So we will conclude that the subtraction of rational numbers is not closed under subtraction. Sum number 4, ancient numbers use the joints of the fingers to count, a practice still seen today. Each finger has 3 joints and the thumb is used to count them. How many can you count on one hand? How does it relate to the ancient base 12 counting systems? Now, if you look into the picture of the palm, we have 3 phalanges. So each one of these lines represent each one of these numbers, namely 1, 2, 3, and the middle finger says 4, 5, 6. Ring finger, each of the lines says 7, 8, 9, 10, 11, and 12. Meaning, out of the 4 fingers, leaving out the thumb, the other 4 fingers, you can count a number till 12. So, how do they count in ancient times? Is once they reach 12 in one hand, say for example the left hand, they raise one finger on the right hand, which is an indicator that a count of 12 has been reached. Once again, if they reach a count of 12 for the second time, they raise one more finger in the right hand, meaning 12 plus 12, 24 has been counted. So in this way, they had been making use of the base 12 counting system. How is this better than the decimal system? Is that the decimal system has got only, that is base 10. It has got only 2 factors, 2, 5. The other 2 factors, 1 and the number itself. But if you consider 12, base 12, so we take the number 12, it has too many factors like 1 and the number itself, 2, 6, 3, 4, so many factors we have, meaning you can very well segregate them in multiples of 2 or multiples of 3 or 4 or 6. So the counting becomes way much easier. So this was how the ancient Indians made use of the base 12 system to count numbers. Brahmagupta's rules for zero. So it has got some 3 rules. We know them very well. When 0 is added to any integer, it gives rise to the same number. A plus 0 is A. When 0 is subtracted from a number, the number remains unchanged, meaning A minus 0 is nothing but A. When any number is multiplied by 0, the result is 0. A times 0 is equal to 0, whichever be the number. If you multiply 0 to that particular number, the resultant is always 0. These are the 3 important rules, the Brahmagupta's rules for zero manipulation. Now, let's look into what are integers. We are expanding still further to learn about more about the next set of numbers, which we can call as the integers. Integers, we very well know they have the positive numbers, the negative numbers, and the zero as well. In ancient India, how did they mean, or how did the positive and the negative numbers were interpreted is that they called them as fortunes or the dana. What are them? They are the positive numbers representing the wealth or the assets which you have. It is on the positive edge. The debts or the rina is like negative numbers representing the debts. So if you consider the number line, if we move towards the left on the number line, Brahmagupta formally introduced the negative numbers to the world. So where do they lie on the number line? To the left of 0. To the right of 0 lies what? The positive numbers. This you can see from the number line shown in this particular diagram. That's how it's been interpreted, the positive and the negative numbers. Now let's look into the arithmetic of integers. How do the arithmetic calculation go about in terms of integers? A fortune plus a fortune is a fortune. 5 plus 4 is equal to 9, meaning a positive number added on to a positive number always yielded a positive number. A debt plus debt is always a debt. Already you are in debt, you have taken some more debt, meaning the debt is more now. In mathematical calculations, it is minus 5 plus minus 4 gives equal to minus 9. A fortune minus 0 is a fortune, a debt minus 0 is a debt. Meaning what we have already studied about the rules of 0. 7 minus 0 is 7 and minus 6. minus 0 is equal to minus 6. Like the number remains unchanged when the number is manipulated with 0, when the operator is either positive or negative. Multiplication, 0 has a higher impact. Any number multiplied by 0 is always 0. The product of a debt and a fortune is a debt, meaning a negative integer multiplied by a positive integer always gives rise to a negative integer. The product of two debts is a fortune. The negative number multiplied by another negative number is always a positive number. Let's look into some exercise problems. The temperature is 4 degrees at noon. By midnight, it drops by 15. So, between 4 and that is 4 degrees centigrade above 0. So, from 4 degree, if it drops by 15, we are supposed to find what is the exact temperature. So, it is nothing but 4 minus 15, which is minus 11 degrees centigrade. A spice trader takes a loan of 80 rupees. The next day he makes a profit of 1200. Following week he incurs a loss of 450. Write the sequence as an equation using integers and calculate his final financial standing. So initially he takes a debt. So that itself is a negative amount in his account. So he makes a profit 1200. So this 1200 has to be added, and then the loss has to be subtracted. 450 is a loss, so the final amount will be 100 rupees. Sum number 3, calculate the following using Brahmagupta's law. Minus into plus is minus. So just multiply and the signs will follow Brahmagupta's rules. Minus 8 times minus 7 is 56. Minus minus is plus. 0 minus of minus 14 is 14. Minus 20 divided by 4 is minus 5. Sum number 4, explain using a real world example of debt by subtracting a real negative number is the same as adding a positive number. 10 minus of minus 5 is 15. That's what they want to prove. Suppose, say you have 100 rupees in your wallet. Now your friend gives you a loan of 50 but he says not to repay. So when you have 100 rupees and he gives a loan of 50 rupees, that means you have to give out 50 rupees from your pocket. So you should actually have 50, but actually he says not to repay. So the amount gets added and becomes 150. If you look into this slide, how do we plot real numbers like 0, minus 5, 5 by 2, which is 2.5, 1 by 7. These set of numbers are called the rational numbers. We will look into what rational numbers are. They are nothing but the numbers which can be represented in the form P by Q, in the form of a fraction. Those numbers which cannot be represented in the form of a fraction, they are called as the irrational numbers. Actually, the number line has got place for the rational numbers and the irrational numbers also. We have already seen how to plot the positive integers, negative integers, 0. All these come under the real numbers. The rational and the irrational also comes under the real numbers. But where do those rational and the irrational number lie on the number line is between any two integers. So the real numbers contain both the rational and irrational numbers. Let's look into some of the key words. What are fractions? That represent parts of a whole. Those kind of numbers are called fractions. Additive inverses, same like how we have additive inverses for every integer, we have additive integers for positive fraction also. In case of a negative fraction, the minus sign can be presented along with the numerator or with the denominator, or a minus sign common to both the numerator and the denominator. Let's look into the rational numbers. Rational number is defined as any number that is expressed in the form P by Q. Okay, where P and Q should be integers and Q should not be definitely equal to 0. This is the condition for a rational number.